Okay, part 1b. We have the same circuit as before, but here we have been told that beta is very large. Okay, beta tends to infinity, and we've been asked to find out what VB, VC, and VE are going to be. Okay, so if beta is going to be very large, and let's assume that we have a finite current here, IC. Okay, let me write it in another color. So let's say IC here is finite, it's not infinite. Okay, if that is the case, what is IB going to be? IB is equal to IC divided by beta, and if beta tends to infinity, IB has to tend to 0, right? So that's the basic idea here, right? So IB equal to 0. Now if IB is equal to 0, what is VB going to be? Now IB flows like this. We talked about this before. This is 10 kilo ohms, right? So what's the voltage there? What's the voltage VB? Now there's no current flowing here, so the drop across this resistance is 0. So VB is equal to 0, right? So VB equal to 0. Now let's assume that the transistor is in active mode. In that case, VE is going to be minus 0.7 volts because there's a 0.7 volt drop across VBE, right, across the base emitter junction. Now, having if VE is that value, we can calculate what IE is going to be, and IE would be given by minus 0.7. So minus 0.7 minus the voltage on the other side of the resistance, which is minus 9 volts. So we have minus of minus 9 divided by 10k. And what's that turn? What does that turn out to be? So that turns out to be 8.3 milliamperes. Sorry, 0.83 milliamperes. That's 10k. So 0.83 milliamperes. Right? Now, if IE is 0.83 milliamperes, what is IC going to be? Now remember, IE is equal to IC plus IB, and because beta is very large, this IB we said tends to 0. Therefore, IE is equal to IC, which is equal to 0.83 milliamperes. And if you know IC, we can calculate VC, right? 9 minus 10k times 0.83 milliamperes, which will turn out to be what? 0.7 volts. That's right. So that's our solution to problem. What problem is this? 1b. And you can check for the active mode assumptions. Now you can see that here the base collector junction is reverse biased, isn't it? The collector voltage is larger than the base voltage. So this is in active mode, and that's what we have been assuming throughout.